Kapil Kumar completed his graduation from Kurukshetra University and did his PhD degree from IIT Kanpur in 2004. His PhD dissertation established as a theory for the numerical study of boundary value problems for singularly perturbed differential difference equations under the guidance of Professor M.K. Kadal Baju, and in 2005 Sir has been awarded with prestigious INIRA postdoctoral fellowship and joined MAB Institut de Mathématiques, France, where he worked with Professor Jacques Henry. Sir has guided 7 PhD students and 3 are working under his supervision. The list of Sir achievements were very large, so without taking much time, I again welcome you all and request Professor Kapil Kumar Sharma to start the event of the day. Sir, thank you so much, sir, for coming here. So I request you to, sir, start the presentation and lecture, sir.
Thank you, Rajat, for giving nice introduction.
Thank you,
And it's my pleasure to interact with the. So, Rajat, who are the participant?
Sir, participants are the PG and UG students, sir. Honors, BSc honors, and MSc honors.
Okay. So to interact with the young blood, and today topic is the approximate information to or solution to the real life problem. So first we should understand that if you observe nowadays that that mathematics is very popular, not only in the subject, across the discipline also. The reason being that if you observe since last 2 decades, because we have computing power, so due to that we are able to now answer the questions which were raised by the societies, and which I'm in trouble to the society, so we can say that. So that's why it's become more popular. So first of all we should understand that how mathematics is useful in answering the real life problem. Am I right? So if you might have observed that there are many real life problem. The most common problem is that we wish to have predictions for the future. Am I right? We would be happy to know the population of Chandigarh. What will be the population of Chandigarh in 2030? Am I right? So this information would be very useful for us in many ways. For example, suppose the population would be so much that we don't have a school for educating our children, so we can make policy to build the infrastructure so that the population at that time could bear. So in that way, this information is very useful. If you observe that in weather forecasting, that how would be the weather in the month of August 2021 of Chandigarh. So this information is very useful in many ways. Am I right? If I say that in financial forecasting, that in the coming week how would be the trend of the market, finance market, so that information is very useful for the investor. So am I right? So to have answer to these problems or this type of problems, we have more than one ways. The one way that if I ask Rajat that how would be the weather of Chandigarh in the month of July, August. So how would be the weather, Rajat? Can you predict in 2021?
in the month of
July, August,
sir, I
or
think without knowledge of mathematics, I cannot predict the weather. But
no,
from the previous
but
data,
but you spend, I think,
yes, sir.
more than 10 year at Chandigarh. So by your experience, you can say that okay, in the month of December, can you predict?
Yes, sir. मतलब it will be a chilly weather over there
Yeah,
in the month.
it would be the winter. Am I right? So that could be, I mean, predicted based on past experiences. Am I right? The another way one can go for the astrologer, but the most reliable information can be obtained using mathematics. Am I right? So that's why mathematics is very useful nowadays. So I have given you one example, mm, but it could be more than one example. Am I right? In many case, if you observe that, we can also uh, find the missing data. Am I right? Using the interpolation. I don't know what is the background of at least PG student must have study numerical analysis as a course.
Yes, sir. BSc second year students and BSc third
BSc
year
second.
and MSc students, they have read the numerical analysis, sir.
Okay. So you are aware about that interpolation, interpolation. So if we have missing data, so using the interpolation techniques which we have in mathematics, we can predict. Am I right? And this information is also very useful. I'm giving you one example. Suppose in a lab, I ask you, my research student, to perform a experiment. And what is the experiment? Suppose I want to observe the temperature of a very I mean precious metal like gold. I ask, I have given my student 10-gram gold, and I ask him to burn it, and observe its temperature, or tabulated its temperature. And he performed the experiment, and he observed the temperature. I think noted down the temperature after 1 hour. So he started from let's start from morning 7, then 7, 8, 9, 10, and so on. Let's assume, being a mathematics student, it's burnt after 6 hours. So he noted down this, tabulated the temperature at different time, and he came back to me. And now this metal is vanished. So he came, and he has shown the table. And I thought, okay, actually I should have observed the temperature at 8:30 rather than 8 and 9, 8:30. So now, what is the way, another way, that one need to repeat the experiment. And that metal is very costly, and of course it's time taking as well. Hmm? One way, that repeat the experiment. Another way, whether can we have some information using mathematics? The answer is affirmative, yes. Without doing experiment, without this, performing the experiment again, we can get the information. And how we will get that? We will interpolate the data. Am I right? So we can interpolate, and using the interpolation, we can get the information at 8:30 as well. So in that way, we can use this interpolation or mathematics to have the to have the missing data. So this is another example. Now the things that how we can use mathematics. Hmm? How we can use mathematics, or how we will use the mathematics while while we are giving answer to the real life problem. So how we do that? First, we will convert our real life problem into a mathematical uh, problem or mathematical model, which we call. Once mathematical model is ready, then then rather than solving our real life problem, we will solve this mathematical problem or mathematical model, and the answer of the mathematical problem or mathematical model will give you the answer of the real life problem. So Rajat, how we can use in whiteboard in this?
Yes, yes, you can, sir.
But for this, how I can write? Can I write?
Yes,
Yeah.
sir. Sir, it is showing to us your whiteboard.
Hmm. And this text, I think, here I can type.
Yes,
Yeah.
yes, sir.
Okay, draw also. Okay. So first, we should understand. I am giving you one. I am explaining this by an example. I think then it would be clear. So first, I am writing you the real life problem. So what is the real life problem? Uh, a road is heating. A road is heating. A road is heating, and we want to measure of the temperature temperature of the of road at different different time and different distance. Rajat, it is visible.
Yes, sir.
Are you
Yes,
able
sir.
to read?
Yes, sir. Yes, sir. It's visible to us, sir.
Okay. Different different time and different distance from heat source. So now I think the problem is clear to everyone. Hmm? This real life problem is clear to everyone.
Yes, sir.
So
It is.
how we can answer this? Anybody can guess, or I mean tell that what we should do in that. A road is heating, and we want to measure the temperature the temperature of the point of the road at different time and different distance from heat source. So anybody answer that? How we should do that? How we should measure the temperature?
With the
Sir.
help of heat equation.
Hmm?
With the help of the heat equation, like in
No, but without using the mathematics, can we answer this? Yeah, of course we can do that. Using the thermometer, we can measure the temperature. Eh? we can measure the temperature at different time and different distance. Wherever we want to measure, so we can put a thermometer, am I right, and measure the temperature. So we can do that. But how many, I mean, data set would be there? Because time, it's also a continuous process, and I mean, the length of the road also has infinitely many points. So if it would be a finite number of points, then we could think about, am I right? But in this case, it is not only, I mean, even in the finite number of cases, the cases are very large, maybe 10 lakh. So even that time also the process is cumbersome, but somehow it's feasible. But in this case, because we have infinite data set, for different time and different point, so this is impossible, am I right, to measure the temperature of the road at different time and different point from the heat source. So now can we answer this using the mathematics? Yes, we can do that. And how we will do that? So now first we will convert this problem. First we will convert this problem into a mathematical problem. So how we will do that? First we should understand the physics of the problem. Let us assume, let u be the let u let u what's happening? What's happening? It's not deleting.
Sir, actually, I think the another one, there are two bars, sir.
Uh-huh.
The text bars are inserted, so that's why it
Yeah,
is not
yeah,
working.
that's why it's yeah. Okay, I'm writing here. Let u be the temperature of the point of a point, rather than I should say that of a point at a at a why it's not writing at a time, say t, and at a point say x. What should I leave? So this thing is clear. So now you tell me, you depend on the temperature, depend on, anybody can answer, I expect from the student. the temperature then depend on.
Sir, I think students are muted from the host control. So that's why, sir, they won't be able to unmute themselves.
Okay, okay, okay. There,
To avoid the
whatever.
disturbance, we have to do it, sir. Sorry for
So,
that.
so how then? I think we should have this interactive rather than one way.
Then
So
I hope,
can you free them?
yes, sir. Yes, sir. I
Only then they could understand and they can ask questions also in between.
Pradeep ji. Hello.
Hello.
Sir, actually, I am talking to the IT team.
Okay.
Pradeep ji, are you there? ਪ੍ਰਦੀਪ ਜੀ ਸਟੂਡੈਂਟਸ ਕੋਲੇ ਹੈਗਾ ਨਾ ਕੰਟਰੋਲ ਮਿਊਟ ਅਨਮਿਊਟ ਮਿਊਟ ਕਰ ਸਕਦੇ ਨਾ ਆਪਣੇ ਆਪ ਨੂੰ ਹਾਂਜੀ ਹਾਂਜੀ ਓਕੇ ਓਕੇ ਥੈਂਕ ਯੂ ਸਰ ਥੈਂਕ ਯੂ ਜੀ
So any student just answer that temperature depend on which parameter?
Sir, mass of the rod.
Hmm.
According to me, sir, mass.
How mass it will depend? I mean, if time increases, so temperature will increase or not?
Yes, sir.
If the point which are closer to the heat source, so these point has more temperature. Am I right?
Yes, sir.
So you basically depend on x, means the distance from the heat source, and t time. This thing is clear. So one thing is clear, because when we are, I mean, modeling a real life problem, or we are converting a real life problem into mathematical problem. So then we need to, first we need to understand the physics of the real life problem. So you basically depend on x comma t. This thing is clear. Now what's happening basically? A heat, we are giving heat to the system, and that heat diffusing along the road. Am I right? That heat basically diffusing in the system. Means what's happening here? We are, I mean, giving heat to the road, and it is diffusing along the length of the road. Am I right? So the rate of change of heat, which is going in the system in the road, that is diffusing in the road. So the rate of change of the temperature is represented by the first derivative. Am I right? Say ut means, if I say that rate of change of temperature, so then what will be rate of change of temperature, rate of change of temperature here? Anybody can answer? The, if I say that rate of change of temperature here, so you should ask this question to me, that in which direction you want to x and t. So if I'm asking with respect to time, so then it will be the partial derivative of u with respect to t, which we denote by u, means u suffix t. This thing is clear. So rate of change of temperature with respect to time, that is we are giving to the system or to the road, and that is diffusing in with respect to x. So basically it's proportional to, yeah, anybody? Hello. Hmm?
Sir, am I audible?
Yeah, yes, yes. No, you are not audible now. So UT basically is proportional to proportional to U. Diffusion is represented by the second derivative. So the partial derivative of U with respect to X, second derivative of the. So UT is proportional to UX X. So now we can use here the proportionality coefficient, say it's C. So UT is equal to C UXX. Now here you have one unknown. If you might have, I mean, did the word problem. So there, what we are looking for actually, how many unknown you have. So we wish to have the same number of equations. So here unknown is one unknown is there. So we have one equation. Am I right? So now we are able to solve this problem. But once we solve this problem, so then we will have the temperature, temperature of the road or point of the road at different time and different point. This thing is clear. So somehow we have converted this original problem into a mathematical problem. Now you look, here, once we have we I mean, we have convert our real life problem into a mathematical problem. The second step, we have to check whether this problem is well posed. When we say a mathematical problem is well posed, when we say a mathematical problem, a mathematical problem is well posed. So anybody can answer? When we say a mathematical problem is well posed, we say, first we have to check whether the solution of the problem exists, the first thing, and that solution must be unique, the first step. And the second step, that the solution must continuously depend on inputs, whatever input we are giving, so that the solution must continuously depend on that, or we can say that the solution must be stable. Stable means if we are taking the small perturbation in input, so that should be, that should imply that there should be small changes in the output. Then we say that a problem is well posed. Number one, when we say the problem is well posed, the number one, the solution the solution of the mathematical problem Hmm? Mathematical problem, or we call it model. Huh? You might have heard this word also, mathematical model. The solution of the mathematical problem exist. Number two, it's the solution is unique. The solution is unique. Third, the solution is continuously depending on the given data or input. Am I right? Then we say that the mathematical problem is well posed. Hmm? So once we convert a real life problem into a mathematical problem, so then we have to check whether this problem is well posed or not. Am I right? So of course it has I mean it has a solution because it's a partial differential equation. Am I right? And it's a c is a constant, and nothing is I mean worrying. If u is sufficiently smooth, hmm? U is sufficiently smooth means its first derivative exists with respect to time, and its second derivative exists, hmm, with respect to x. So then, hmm, it has a solution. Now we will check the second one. The solution is unique. So tell me whether the solution of this problem is unique or not. Unique, you understand? The one solution only. So anybody can answer whether it has a unique solution or not.
Hello,
Hello.
yeah, student. You can also type your answers in the comment box, and I will recite to the professor Kapil
Yeah,
Kumar.
I think that would be a good way.
Yes, sir.
Hmm. But your voice, Rajat, is echoing.
Uh, I will check. Just a minute.
So my voice is clear.
Yes, sir. Your voice is clear, sir.
Now
You are
now
audible,
now
sir.
your voice is also clear. So okay, so anybody can answer whether it has a solution. So yeah, so I clarify that it has a solution, and its a second derivative exists, with respect to x. So then this problem has a solution because is there. So it has. Anybody can answer? Yeah, I'm waiting for the answer. Whatever you think.
Students, what do you think? Whether it is a whether this problem has a unique solution or not?
So I think has a unique solution.
It has a unique solution. How we will solve this problem basically? Basically, because I am not looking for ut, I'm not looking for uxx, I'm looking for u. So for u, what I need to do, I have to integrate this with respect to, once with respect to time and twice with respect to x. So when I am integrating this with respect to time, so we have one parameter, family, which depend on x. And when we are integrating with respect to x, so then we have two parameter family, which depend on only on t, which is independent of x. So it means that three parameter we have once we solve. So it means it has infinitely many solution. Am I right? So to have unique solution, we need to specify, eh, or we need to eliminate these three parameters, and to eliminate these three parameters we require three conditions. Am I right? So in that way, we will specify the condition. So first we will specify the condition with respect to time. So we can have the temperature profile of the road initially. Am I right? At each point of the temperature of the road, when before, I mean, starting the experiment, hmm, or process, we can say that suppose it is given by fx. This is the temperature profile initially of the road. So one condition is this. Now we can keep the temperature of the road, or of the road at the end point of the road. Some we can fix some temperature. Say we can kept that 0. We I mean, we have frozen both the end of the road. So temperature is for all time, temperature of the road, when x is equal to 0 is equal to temperature of the road. Suppose L is the length of the road. L is the length of the road is equal to 0. So now we have, now this has three condition. So this is a, now this is the mathematical model or problem which has a unique solution, and this is known as the heat equation. If you might have heard with these three, first is known as the initial condition, because initially the value is known, and this is known as the boundary condition because the data is given on the boundary. So this problem is well posed. Am I right? Well posed in the sense we can say that under certain condition that if f is smooth, belong to C means it's a continuous function. So in that case, this if we make, because what is the given data here, because f is known to us. So if we are making a small change in f, so that will give a small change in u. This thing is clear. So once we have this, now rather than this one, so we have this. Am I right? A well posed mathematical problem. Now rather than looking for measuring the temperature at different time, we will solve this mathematical problem. And what type of solution this mathematical problem has? Its solution will be a function of, suppose it's a g is a function of x and t. Am I right? This type of thing we will have. This thing is clear. So this type of solution we have u is equal to gxt, means a function of x and t, if you remember. And fortunately, if you know that we have procedure to find the exact solution of heat equation. I hope that the master student must have done. Anybody can tell how we will solve this problem using a method of, you can assume that this as a product of function of tt and function of xx, and then this is reduced to the ordinary differential equation to coupled or ordinary differential equation, and you can solve, because partial differential equation are very complicated, to find their solution. So we convert that into that, and then we solve two uh, ordinary differential equation, and that gives you the answer to this problem. And so I'm not going to solve this problem, but I'm telling you that you will get an answer in that format. Means it would be some x function of x and t. Now suppose, and this g is known to us, so now suppose we want to measure the temperature of the rod at 1 meter from 1 meter from 1 meter from heat source, and after 2 hours. So we can put this in g, and we will get the value. So now you have this formula, and with the help of this formula you will get the temperature, without measuring or without performing anyway. So in that way we use the mathematics. So I have given you one example, it's a one toy example I have given. I have given you one toy example, but similar thing we do in weather forecasting. If you look the mathematics behind the weather forecasting, so we solve a system of partial differential equation, a system of partial differential equation, model that phenomena, and then we try to solve. But you observe, you might have observed that before 10 year, or maybe when we were young, 20 year before, so the weather forecasting was very uh, i mean uh, very rough. I should say rough in the sense that unreliable. And sometime what's happened, they predicted that it would be heavy rain, and it seems that after 2 hours sun is very bright. So sometime the forecaster, what they used to do, rather than believing on these mathematical models, they just looking from the window, and if they find that okay, it seems to be very I mean uh, cloudy weather, so they say okay, in after 2 hours it would be very heavy rain. But unfortunately sometime it's happened that they predicted that it would be very heavy rain, and after 2 hours it was a sunny day, very bright sun day in the sky. So I mean to say that so that time, if you compare the mathematical model, model which model these weather predictions or weather forecasting in used in weather forecasting, are not much advancement is there. But where is the advancement? At that time we are not uh, able to find, or we don't have any procedure to find their exact solution. And of course the computing power is also less. So now till then what we did, we have procedure to, because once we model this real life problem into a mathematical problem, so our next task is to find the solution of this problem. And fortunately for this model problem, we have the solution, we have the method to find the exact solution of this problem. But in reality it doesn't happen. eh? In reality it doesn't happen. Why it doesn't happen? If you observe, or we can say that a mathematical problem which model real life phenomena are very complicated in nature, are very complicated in nature, and we are not able to find their exact solution. So now the question here, so if we don't have any procedure to solve a mathematical model exactly, so whether we should leave that model and we should go to another model, another simplified model. But when we go for the simplified model, so it may be that we are very far from the real life problem. Am I right? So now whether the approximate methods or approximate information or approximate solution of a mathematical problem or matlab serve our purpose, the answer is affirmative, yes. eh? In most of the practical, now I am claiming that. So till now, I think first we should ask whether anybody have any doubt. Rajat, can you ask, write in a chat box? Anybody have doubt till
Students,
now?
if you have any doubt, you can write down in the chat
Write
box.
down or just I mean that person can raise hand so we can unmute his mic only.
Sir, like when you said to solve the partial derivatives to get the solution of u.
So first tell me about yourself. Who is?
Sir, myself Divya Gupta. I am from BSc third year.
Good.
Sir,
Yeah. Now
I wanted to ask, like when you said that it's difficult to solve the partial derivatives to find the solution of u. So you said that we'll separate the functions like of in product form, like a function of t with the product of x. So how can we do this? Like some functions are like we cannot separate them.
Yeah. So that's why I'm saying. But for this particular problem, did you study heat equation? No. So in I think master first year maybe you will study. So fortunately, particular this problem, am I right? We can use that. We can use that method, but in journal note. So that's why I am saying that very few mathematical problem or mathematical model, which model real life problem for which we have method to find their exact solution. So you made my task easier. So if you observe in differential equation itself, in differential equation are very few differential equation, even ordinary as well, I'm telling you, for which we have the exact solution. That's why you might have heard Legendre differential equation. You might have heard Legendre, Bessel. Am I right? These are the second order linear equation. Am I right?
Yes, sir.
Second order linear equation, and I think Legendre gave the solution. That's why that differential equation is known as behind his name. So I mean, that's why I am saying that very few problem for which we can find the exact solution. So that's why the one way that we should leave that part, for which we cannot find the exact solution, but they are giving I mean very realistic modeling of a real life problem. So that's why we are interesting to keep them. So the another way, whether we can find their approximate solution. Am I right?
Yes, sir.
Yeah, one thing, whether we can find approximate solution. So the of course answer would be yes, we can find that. Once that, now the second thing that we should see whether these approximate information or approximate value of the solution serve our purpose. So I am claiming here, now I am claiming now I am going to the next topic. Here it's, I mean, how to delete that. So anybody else should I, yeah, tell.
Good morning, sir.
Good morning.
Sir, myself Smith Kumar from MSc first year.
Yeah.
Sir, my question is that what is the position of point with respect to light source when we have considered that x is equal to 0?
Pardon? What is?
Sir, we have considered that the value of temperature at any time, but x is 0.
Here you are
that
saying
is
that,
0. Yes, sir.
in this one. Yeah.
No, sir, next one. ut0 is equal to 0.
ut0, yeah.
Yes, sir. Then what is the condition of the point with respect to heat resource?
With respect to means suppose heat source in some between the road, am I right? So from here we are calling it 0, am I right? We are calling
Yes, sir.
the 0 endpoint, and this is the length, this is the endpoint of the two endpoint you are taking. This 0 x is 0 and this x is equal to L. It's fine.
Sir, then how we can say that temperature is 0 at that position?
No, but we have to. What I am saying that because to have the unique solution, so we need to specify. We need to specify the the condition, three condition. Am I right? So how we can specify the condition? भाई कहाँ हम भाई ऐसा तो है नहीं जब हमने एक बार एक्सपेरिमेंट शुरू कर दिया तो बीच में तो नहीं कर सकते, तो हम कहाँ जो है कंडीशन स्पेसिफाई कर सकते हैं? इनिशियल और एंड पॉइंट पे. इनिशियल मतलब वी वुड बी अवेयर ऑफ द टेम्परेचर ऑफ द रोड व्हेन टाइम वाज 0, एक्सपेरिमेंट जब हमने स्टार्ट नहीं किया है. ऐसे ही एंड पॉइंट पे हम क्या कर सकते हैं कि भाई टेम्परेचर को मेंटेन कर सकते हैं. सपोज करो हमने 0 टेम्परेचर मेंटेन कर दिया, अभी दोनों साइड, दोनों जो उसके मतलब रोड के सिरे हैं उन्हें क्या किया हमने, फ्रीज कर दिया. ठीक है, मतलब बर्फ में रख दिया तो वो टेम्परेचर 0 रखेगा ना एक टेम्परेचर मेंटेन करने के. सो दैट इज फिजिबल. एम आई राइट? Doing the experiment or to have our problem well posed, so we can specify the condition on either on the boundary of the domain or initially. Yeah. Anybody else? So that I will now rub this and I will move to the next topic. Rajat, should I rub this?
Yes, sir, you can, sir.
So now we are coming to the approximate methods to find.
Hello, sir.
To find. Yeah, yes.
Sir, I have one question.
Yeah, tell.
Sir, what do you think about the superconductivity in our real life?
No, I'm not, I mean teaching here the physics. Am I right? I'm teaching what I claimed at the beginning. I claimed that how mathematics is useful to solve real life problem, and I am trying to convey that how we use mathematics to solve the real life problem. So in that way I have given you that example. Am I right? So we are not studying here physics. So just I want to convey that how we will use mathematics to answer the real life problem. First we will convert that into a mathematical problem or mathematical model. Once we have converted the real life problem into a mathematical problem, then the next step, the well posedness we will discuss of the problem. Once we have prove or I mean drive the well posedness of the problem, the second is the solution, or I should write here the solution of a mathematical model.
Okay,
Am
sir.
I right? So my
Yes, sir.
objective is that solution of a mathematical problem or model. This thing is clear? Yeah, anybody else? Should we move to this one?
Yes, sir, please, sir.
Yeah, so solution of a mathematical model. So fortunately, whatever example in the last slide we have given, so for that we have a solution, or no, not we have solution means we have a procedure. Once we say that the problem is well posed, it means it has a unique solution. Solution would be there, but we generally we don't have a procedure to find the exact solution of a mathematical model which model real life problem. So now we will talk about the solution of a mathematical model or mathematical problem. This thing is clear. So of course I claim here that we don't have much procedure to find the exact solution of a mathematical problem. So now we come to the approximate solution of a mathematical model. This thing is clear. But the second step is the approximate solution of a mathematical problem. So now we have to justify here whether this approximate solution will serve our purpose. Now I am claiming that my claim is that in most of the practical problem, most of the practical problems or situation, practical problem or situation, the approximate information or solution serve our purpose. So this is my claim. Can we color this?
Yes, sir, I think below there is an annotation, sir. In that you can color this.
Where?
Sir, I think there is a below there is an annotations bar.
Acha, where I am not able to see. Stamp, spotlight.
There is a text color, I think.
Where is that annotation? Edit.
I think might be, sir.
Yeah, here I think. Oh, but entire format will be.
Yes, sir.
Oh, yeah, it might be. Oh, no, it will not go. Clear, drawing clear.
You can undo this, sir. Undo this.
Undo, yeah. From here, but it's all undo. Clear, drawing clear. How to remove that? Okay, so my claim is that in the most of the practical problem or situation, the approximate information or solution serve our purpose. So I will give you some example. Number one, Number one is weather forecasting. Number one in weather forecasting. So suppose I'm planning my journey to visit your place on coming Sunday. So the information that whether it would be raining day or non-raining day, this information is sufficient for me to plan my journey. Am I right? If it would be raining day, so I will go with umbrella, or maybe I will start my journey little, taking some advance time. Are you agree? But in case it would be sunny day, so then I would be happy without I mean I will go, or I will plan my journey accordingly. So the information whether it would be raining day or non-raining day, this information is sufficient for me, or for many practical purposes, rather than how much it would be exact, how much raining would be there, or whether it would be heavy rain or I mean moderate rain. This information is sufficient rather than how much rain exactly would be. Number two, or if you observe in the western country where the sun shine rarely, so there the information whether it would be sunny day or non sunny day, this I mean information is very useful for them. Am I right? In population forecasting, in population forecasting population forecasting, that how much would be the population of Chandigarh, hmm? How much would be the population of Chandigarh after 10 year, after 10 year. So let us assume exact would be that maybe suppose it's exact would be 10 lakh or 20 lakh. 20 lakh, maybe I say 20 lakh.
Didn't get that. Could you try again?
Yeah. So let's assume the exact information is 20 lakh 200. Am I right? Or approximate it's if I say that it's 20 lakh, so this 20 lakh it's I mean sufficient. Sufficient for administration to I mean make their policy. Am I right? Or maybe it's 20 lakh 2000. So this approximate information serve our purpose in weather in financial forecasting. In financial forecasting.
Uh-oh, something's wrong. Please try again.
What's happening? Oh, yeah. Yeah. So in financial forecasting, the information that whether in the coming week, whether the market in the upward direction or a downward direction, this information is sufficient for an investor to invest the money in the market. Am I right? If it would be in the upward direction, so the investor will invest the money in the market. If it is a downward direction, so investor will withdraw the money. So this thing is clear to everyone. So I mean to say that in most of the practical situation, we are happy with the approximate information. Even we don't require the exact information. So this thing is clear. Any doubt? Are you agree with my claim?
Yes, sir.
So that's why we go for the approximate methods to find the solution of a mathematical problem. This thing is clear. And now how we use to develop the approximate methods? I will explain this using now the third, the development development of mathematical methods to find approximate solution of a mathematical problem. So development of mathematical methods for to find the, or I should say that, an approximate solution of a mathematical problem. This thing is clear. Now how we should or how we will develop. So I will explain this using a method, using a an example. I will demonstrate this. Suppose we wish to solve this initial value problem. Y is equal to, y prime x is equal to f x comma y, where y is the dependent variable and x is independent variable, and y, it's an initial value problem. Y at 0 is equal to y at 0 is equal to, say, y 0. So this is a first order initial value problem. It's a well posed problem, provided that a certain condition on f would be there. So what are the conditions when this problem has a unique solution? Anybody can answer? It's an initial value problem. I think master student must answer. They must have studied this. It has a unique solution.
Yes, sir. They have read about the existence and uniqueness theorem.
Yeah, exists. So tell me, what is the existence and uniqueness theorem?
MSc 1 students. I think that might be due to some connectivity issues. So I think might be due to some connectivity issues. The MSc 1 students are not there.
Okay.
Yes, sir.
Okay. So that provided that f satisfying the Lifshitz continuity condition. If f is satisfy Lifshitz continuity condition, so then it has a unique solution, and of course this solution continuously depend on continuous on input. On if we are changing, if we are making a small change in y0, so then there will be small change in y solution. If we are making a small change in f, so then there will be small change in y. So it means that it has a unique solution, and the solution continuously depending on the given data. So it is a well posed problem. So now we are talking about its solution. So can anybody give me the solution of this problem? First we will try to find its exact solution. If we would not be able to find the exact solution, so then we will move to approximate solution. Am I right? So Rajat,
Yes, sir.
can anybody answer?
Yes, students. Do we know about the exact solution of this problem? Hello. Yes, Shakti.
लाया फोन तेरा फोन फोन तो पढ़ ला
Sir, I think there might be some problem because the students won't be able to switch on their mic.
Okay. So they can answer in the chat box. So okay, now I am just telling you, just you verify. So we don't have any procedure to find its exact solution. Am I right? In particular cases, in general, we cannot find. In particular cases, suppose f is a function of a separable form it has, so then we can find. But in general, for general f, we cannot find, or we don't have any procedure to find the exact solution of the problem. Exact solution of the problem. So you people can verify this. So now we will try to find the approximate solution of the problem. So how we will do that? So let being a student of mathematics, we will use our very important tool. Let y be the solution of the above initial value problem. This thing is clear. Let y be the solution of initial value problem. What does it mean? It means that y satisfying this differential equation as well as satisfying this initial condition. This thing is clear. So now rather than solving this problem, my objective to find y in some known form. So I'm looking for y x is equal to something in the right hand side, which should be known. So I'm trying to do that. And what I know the solution, this function y around x naught. So I will try to insert x naught. How we will do that? I write x naught, I add x naught and subtract x naught. Is x minus x naught. This thing is clear. So x naught will be cancelled out. So now because I know the solution at this point around x naught, so I will expand this right hand side around x naught by the Taylor's method. By the Taylor's method. So what will be? It will be y at x naught plus x minus x naught, x minus x naught into y prime at x naught. This thing is clear. Square divide by 2. Am I right? Whole divide by 2, or I can write here 1 by 2. Y double prime at x naught, and it is an infinite series plus. So this thing is clear. So now we look that on the, if everything is known in the on the right hand side, so then it's fine. We have done. So now look whether this first term is known to us. Whether this first term is known to us.
Yes, sir.
Yes.
Yes, sir.
This tell me, this x minus x naught is known to us or not? Yeah, tell. This is also known to us, where I am looking for the solution at point. So that point it is given to me. X is known to me. Where I
The
am looking.
distance between x and x naught.
Yeah, so it is known because where x naught, it's a point. Because it is defined, this is an operator, so we can say that this is true for all x belonging to in all x belonging to in an interval I. Am I right? Where I is contained in, where I is contained in R, real line. Am I right? So it is an interval. So this is true for this, and let x naught, if I write, let x naught a point in I. So then the value of y at x naught is given. So it means that where I'm looking for the solution at that point, so that is also known. So this x minus x naught is also given to me. Now I'm looking for y prime at x naught. That is, this is known or not? Hello?
Yes, sir.
So this is known?
Yes, sir. Yes, we can. If yes, sir, y prime is f of x comma y.
Yeah, so this is known because f x comma y is also given. So this is known. Am I right?
Yes.
Now we are coming to the third one. 1 by 2, it's a constant value. This is second one. This is also known to me. Now I am coming to y double at x naught.
Hello. Yes, sir.
Yeah, so whether y double prime at x naught is known to us or
Yes,
not?
sir. Take a derivative, total derivative of f function once, so that we can get the value of y double prime.
Yeah, so we can find y double prime. We can find y double prime at x first, and then we will try to find. So this is nothing but dy prime by dx. Am I right? That is equal to df by dx, and f is a function of x and y, so we will use the chain rule. So by chain rule, df by df by dx into dx by dx plus df by dy into
dy by dx.
dy by dx, and that is equal to f. If I write in the suffix form, partial derivative of, because f is a function of f is a function of x and y, so it will be partial derivative. Rather than d, I should write pd, partial derivative. Partial derivative symbol. Here also it's a partial derivative. So partial derivative of f with respect to x into 1 dx by dx1 plus partial derivative of f with respect to y into y prime, and y prime is dy by dx is y prime is f. So here everything is known, so we can also can calculate this. Similarly, y triple prime we can find, so we can find this everything we can. So everything is known in the right hand side. Yx and whatever written in the right hand side, so everything is known. So now you should ask, sir, but you are claiming that so still we have problem, because we have infinitely many term. We cannot add infinitely many term. Arbitrary infinitely many term we cannot add. We can add, okay, if something like that 1 plus x square by 2, this thing up in particular pattern, if a series had, so in that case we can have, but in general we cannot add. So that's why we have to truncate the right hand side after a finite number of term. Suppose I have truncated after this, so then I will get the answer, but now this is not equal to, this is approximately equal to. Am I right? So in that way we develop the approximate method to find a mathematical solution of a mathematical problem. So I think I should stop here. And if anybody has any doubt, any comment, so most welcome, and thank you for your patience.
Thank you so much, sir. Thank you very much. So students, if anybody has any doubt, you can write down in the comment box. And I request Dr. Alka Munjal to recite the doubts of the students. Yes, students, please. You may ask your doubt in the comment box. I think the students already asked the doubt while in the lecture, so at then they have no doubt.
So okay, thank you.
Yes, sir. So thanks to you, sir, for this wonderful lecture. So now I would like to invite Dr. Sandeep Singh to say word of thanks to our audience and our guest speaker of the day. Dr. Sandeep Singh, am I audible to you?
Yes, sir. Yes, sir. So, good morning, everyone. Yes, sir, am I audible?
Yes, sir.
Good
Yes, sir.
morning,
You
sir.
are audible.
So, it's a wonderful session by our respected speaker, Professor Kapil Kumar Sharma. And sir started from very basic example, that is the heat equation. And with the help of this example, sir takes us to sir gives us the idea about the mathematical modeling and how we can use the mathematical models to convert daily life problem to the mathematic problem. And after that, sir gives us the idea how to find the solution of that problem. And it's quite interesting. If we have not exact solution, then we have to go for the approximate solution. So maximum of us are familiar with the theoretical aspect of you can say this approximation theory, but in today's lecture, sir gives us the idea about the practical knowledge of this topic. You can say the application theory. So also, this is not interesting for only for me. This is also the interesting topic for my students, because the overwhelming number of questions from the students tells us that they are taking interestingly part in this webinar. So on the behalf of the department, I would like to thank Professor Kapil Kumar Sharma for accepting our invitation and sparing their precious time with us. And I also thankful to the university administration, my colleagues, my dear students, and especially our department in charge, Dr. Mr. Rajat Singla, soon will be going to become a doctor. And after that, one most important department, that is our IT department. And because without their help, it is not possible to conduct such online meetings. So thank you everyone, and thank you, sir.
Thank you, Sandeep.
Thank you, sir. So with these words, I'm going to end the meeting, and thank you.
Thank you, sir. Thank you, sir. Thank you for sir coming and giving us a enlightful lecture. So I wish we will meet soon in our university as well. We will invite you whenever the pandemic situation will end. So I hope, sir, you will accept our invitation to coming to Akal University. So we will meet soon, sir.
So Rajat, where it is?
Sir, it is in Bathinda, sir, in Punjab.
Bathinda. Okay. Yeah. Okay, great. Sure, I will come. Okay.
Thank you so much, sir.
And best of luck for your PhD. So did you submit your thesis or just about to submit?
Sir, just about to submit, sir. I am going to start writing my thesis in the month of maybe February or March.
Okay. So you are working with whom?
So Dr. Gurjinder Singh, sir.
Acha, so where he is Gurjinder nowadays?
So sir is in sir Kapurthala, sir. IK Gujarat, Punjab Technical University.
IK Gujarat. Okay. Good.
Yes.
Okay. Best of luck. Okay, bye.